Natalia, did I pronounce your name right? Hello?
Yes, ma'am.
Natalia, right?
Yes, ma'am.
Awesome. So we have Elaine, Ashley as well. Let me mark your attendance in Starfish. We have Elaine, we have Ashley. Natalia. We have 1 more minute, but let's wait a little bit longer. First time. Okay, it's 6:01. I'm going to mark other people as absent. Lane is here, Ashley is here, Braxton. Are you able to see my screen?
Yes.
Yep, it looks good.
Awesome. Aiden, Natalia's here. Lauren. So far we have 3. One is joining. Let's see who is. Lauren. Okay, perfect. Safe. All right. So hello guys, my name is Betty Guo. I'll be the instructor of this essential and your QR class. The essential class is to serve the QR class. We mainly work on assignments and have you understand the content and the concepts. Last night actually, I emailed you about a few things. I want to ask you, have you finished those? Have you completed those tasks? Have you emailed
Yes.
me the introduce yourself and respond to my greeting email? Have you registered in MyLab Math? And let me know. Do you mean to show you again how you register in MyLab Math? If you don't want to talk, you can. Okay, there's a message here. Not yet, but I will right after this. Okay, that sounds good. And I also want you to tell you, I just made the class videos for the first chapter. You should be able to find them in your Blackboard. I can show you right now. So if we go to QR class, And as you can see in the menu, last item is class videos. You click class videos. Give it a little bit of time to respond. And you see a sandwich here. Click this sandwich. And the last item on the menu is recordings. Click recordings. And you will see the two sections, class videos I just uploaded. And study them and then work on the homework. All right. The first section is about two reasoning processes, induction and deduction. And the second section, 1.2, is about estimation. How do you round numbers and etc. And today, as an essential class, as the foundation, we are going to talk about the order of operations. Let's see here. I'm registering for Mlm right now. Still need help. Couldn't get mine to work. I'll talk to you, Lauren, after the class. All right? Yeah. We'd better meet in Zoom. That way you can show me, you can share on your end. In this classroom, virtual classroom, I am the one that could share only. I am registered and have sent emails. Thank you, Natalia. All right, so let's start our lecture. Yeah. So we are going to talk about order of operations. Order of operations. Operations includes addition, subtraction, multiplication, division, exponentiation, radicals, and etc. So when we have multiple operations in one algebraic expression, what's the correct order to process those operations? Should we do the multiplication before the addition or the division before the subtraction and so on? Do we have a certain order? Yes, we do. So here, today we are going to talk about the rules of the correct order of operations. We have 3 rules, so please take notes. Rule number 1. The first rule of the correct order of operations is, please excuse my dear Aunt Sally. So some books or some teachers call that PEMDAS, the initials of those operations. Let me explain. It's pretty easy to remember, right? Please excuse my dear Aunt Sally, or PEMDAS. P here. Oops, my bad. Give me 1 second, let me fix that. Okay, so P here represents parentheses. P here represents parentheses. And other grouping symbols, such as brackets, braces, or even absolute values. Those are all seen as grouping symbols. So P here represents parentheses, but it also refers to all other grouping symbols. When we have grouping symbols in an expression, we should always take care of the content in the grouping symbol first. Let me double check, am I recording this or not? Oh, yeah, I'm recording. Awesome. So you should be able to watch the video again after. And E here represents exponent. Okay, yeah. So this is a QR class. QR class means what? Means you have prerequisite classes completed successfully, such as algebra foundation class, right? Yeah, what is exponent? What is the operation of exponentiation? For example, anyone can help me to evaluate this expression. Let's say 5 to the power of 3. Okay, yeah. And another one, we're going to see how do we find 3 to the power of 5. Exponentiation has two parts, right? The number on the bottom is called a base. The number on the bottom is called a base. The number on the shoulder of the base is called an exponent. Together, that is one expression. Yeah. So yeah, I heard someone respond. You can unmute yourself and let me know. Yeah. What is 5 to the power of 3? How do we use the base and exponent to evaluate this power or exponentiation? Huh? Yeah, you can unmute yourself and let me know your answer. So exponentiation is a repeated multiplication, right? Yeah, exponentiation is a repeated multiplication. 5 to the power of 3 represents a repeated multiplication in which the base 5 is used as a factor. How many times? Repeatedly. How many times? 3 times. So we have 5 times 5 times 5, and that gives us 125. Do you have the same thing? Yeah, I don't mind you unmute yourself and talk, okay? Yeah. Is that right?
Yeah.
Okay, very good. And what about 3 to the power of 5th? Yeah, 3 to the power of 5th. Yeah, the two expressions looks very similar, right? Yeah, only the order of the two numbers is different. Yeah. 5 to the power of 3, base is 5, exponent is 3. 3 to the power of 5th, base is 3, exponent is 5. And that
Yes.
makes a huge difference. That makes a huge difference. Yeah. So 3 to the power of 5th, this exponentiation is also a repeated multiplication. In a repeated multiplication, we use 3 as the factor repeatedly. How many times?
Uh,
1, 2, yeah, 5 times. 3, 4, 5. Yeah. In this course, calculator is allowed. Actually, is encouraged. Okay, encouraged. Oh, my bad. So it's 3. I was thinking about 3. Yeah. 1, 2, 3, 4, 5. Yeah. So anyone can tell me what is the answer? 27 times 9. 27 times 9. What is it? 81, 2, 4, 81 times 3. 243. Am I right?
243. Yes.
Okay, very good. So that's the basic about exponentiation. Yeah, let me challenge you a little bit more here. Let me challenge you a little bit more here. I'm going to give you another two expressions. The first one is I have parentheses. In the parentheses, I have negative, say, 2, no, negative 3. And we raise negative 3 to the power of 2. This is one expression. Another expression looks very similar, but it's different. And then type it. It is -3 to the power of 2. And when you take a notes, those are important examples, okay? Yeah. So let's look at those two expressions. Look at them. So similar, right? Yeah. What's the difference? This expression has a parentheses frame 93 as the base. On the shoulder of the parentheses, we have power 2, second power. And the second expression, we do not have the parentheses, right? Yeah, we do not have the parentheses. What does that mean? What difference that makes, guys?
I don't know.
What's the base of this expression? What's the base of this expression?
-3.
Exactly. Yeah, exactly. -3. So the power is 2. That means we are using the base -3, -3 twice in the repeated multiplication, right? Yeah. What is 93 times 93?
Not +9.
+9. Awesome. Very, very good. Thank you. +9. And the second expression, what's the base? What's the base?
-3.
The base is 3 only. Yeah. How do we understand the negative sign? If the negative sign is not part of the base, okay? Yeah, that's the difference the parentheses makes. In this expression, the negative sign, we can understand the negative sign as the opposite. The opposite of what? 3 to the power of 2. Second power. See that? Yeah. For example, what is opposite of 5? Do we remember what is opposite? What is opposite? For example, what is opposite of 5?
-5.
Yeah, you just put a negative sign in front of it. Okay? Yeah. So whenever you place a negative sign in front of a quantity, even an expression, yeah, whenever you place a negative sign in front of something, you get the opposite. All right, let me do it again. The opposite of 5 is -5. Okay? And what's the opposite of -5?
+5.
Opposite of -5 is +5. Awesome, exactly. You see that? Yeah, so here is a trick, and I hope you can see it. Whenever you place a negative sign in front of whatever either a quantity or number, a variable or expression, the negative sign serves as opposite, okay? Serves as opposite. So negative, this negative sign in front of the power has nothing to do with the negative sign at all. Okay, the structure of the expression, the structure of this expression actually is the opposite of 3 to the power 2. Can you see that? Yes or no?
Yes.
Yes? Okay, very good. So what is 3 to the power 2?
9.
9, yeah. Then what is the opposite of 9?
-9.
Here we go. Do you see the difference of the two expressions? They have different values, right? Yeah, this is a +9 and this is a -9. Yeah, please see the difference of the two expressions. They have different structures. When you learn algebra, seeing the structure is so important. How important? Like it's just like when you, let's say you are a doctor or a nurse. Is that important for you to see the anatomy of a human body? You know where's the liver, where's the heart, right? Yeah, where's the vessel, everywhere in the system. Yeah, so it's important to see the anatomy. Anatomy is kind of like structure of human body. If you are an architect, then isn't that important for you to see the structure of the buildings, right? Yeah, what is outside, the inside, how does the goes, the way it goes. Same thing, when we learn algebra, it's very important for us to see the, you want to say this word aloud. To see what? To see the structure of the expression, all right? To see the structure of the expression. I hope you see the difference in the structures of those two expressions. They are different. In this expression, with the parentheses, it indicates the base is -3. And this, without the parentheses, that means the power has nothing to do with the negative sign at all. The negative sign is placed in front of the power. You can translate that negative sign as the opposite. All right? Yeah, that's something. Yeah, questions? Questions?
So
Yeah, let
you,
me check
so,
the chatting.
yeah,
Uh,
so
so do you have any
if
questions?
I do, yes,
Yeah,
you have
what
to
is it?
raise your hand. Okay, so with the second one that doesn't have the parentheses around it, you just kind of ignore the negative sign in front of it, solve it, and then put it back.
Yeah, exactly.
Okay.
And you actually apply the order correctly. Yeah, you
Okay.
ignore it because the power has nothing to do with negative sign. And then you calculate what is 3 to the power of 2, 9, and then put it back. Exactly.
Okay. Okay.
Yeah, you attach back. Awesome, awesome. Is Natalia right?
Yes.
Very good, very good. Yeah. So that is PEMDAS. E means exponent. Let's continue. Our focus here today is the order of operations. So that's E. M here represents multiplication. Yeah. Multiplication. And D here is division. A here is addition. S here is subtraction. Okay, so Tamadas means if in an expression we have multiple operations, we have grouping symbols, so we have plus, minus, multiply, divide, and that's the order. That's the order. Yeah, P first, take care of the content in the grouping symbol first, and then do the exponentiation. After you do the exponentiation, you take care of multiplication and division, and then you take care of the addition and subtraction the last. All right? Yeah. So that's the first rule. That's the first rule. The first rule is a little bit misleading. Yeah, some students only remember the first rule, so that's why they make mistakes when they have something uh, have some expression like this one. I'm going to write it down, okay? For example, if you have this expression, you have 1 minus 2 plus 3. Yeah. This expression has a subtraction, has addition. If we think about the PEMDAS, it seems like addition should go first before subtraction, right? But no,
Yeah.
that's what I'm going to talk about in rule number 2. Yeah, in rule number 2. Let's say if there are only additions and subtractions in an expression, if we only have additions and subtractions in an expression, we go from the left to the right. Okay, we go from the left to the right. Addition and subtraction are at the same level. PEMDAS, please excuse my young Sally, does not mean addition should always go before subtraction. No, not at all. Not at all. I'm emphasizing that, stressing that. Rule number 2, if the expression only has additions and subtractions, we should always go from the left to the right. In this example, we have 1 minus 2 plus 3. So from left to the right, do you see the subtraction first or do you see the addition first?
Subtraction.
Yes, subtraction first, then we should take care of the subtraction first. What is 1 minus 2?
1.
1 minus 2? You In the casino, you win $1 and then you lose $2. So what's the answer?
Oh, negative.
One, yeah, negative one. Okay,
Negative.
yeah. And then bring down +3. Yeah, we take care of the subtraction. Yeah, we take care of this part. 1 minus 2. Let me see if I can change the color. Change it to red. Yeah. So that part, the red part give us this red part, right? Yeah. So the first step, we take care of the take care of the subtraction because we see the subtraction first from left to the right. So 1 minus 2 is -1. And then we bring down +3. +3 is still in the expression. And then we take care of the addition. Yeah. Firstly, in a casino, you lost $1 and then you make $3. So how much do you have?
You have $2.
$2. Yeah. Then -1 plus 3 is 2. So that's the answer, right? That's the answer. Yeah. So if you misunderstand the first rule, do the addition first. And you have 5, and 1 minus 5 give you -4. The answer would be incorrect. The correct answer is 2. Yeah. Again, rule number 2, if the expression only has additions and subtractions, we should always go from the left to the right. Go from the left to the right. All right. Rule number 3. Rule number 3. If there are only multiplications and divisions in an expression, what's the order of the correct operations? We go from the left to the right. Yeah, similar with earlier. PEMDAS seems like a multiplication should go before division, right? Not necessarily. Let's say if we have 10 divided by I would have to find the division symbol here. Yeah, here. Divided by 5 and then multiply more symbols. Oh, right here. Multiply by 3. Yeah. How about, no, hold on. Multiply by 2. More convenient. 2 is more convenient. Multiply by 2. Yeah. So if you misunderstood PEMDAS, the rule number 1, you might do the multiplication first. And you have 5 times 2 is 10. And then you take care of the division. 10 divided by 10 equals 1. But that is incorrect. All right. The correct way is to follow rule number 3. When the expression only has multiplication divisions, what do? We go from left to the right. When you read a book, you read from left to the right, right? When you read something on your cell phone, go from left to the right. So that's the correct order. So we are going to take care of the division first. We call the division first. 10 divided by 5 is 2. And then multiply by 2. What do we have? We have 4, right? Okay, the red part is the first step. Is the result from the first step. Is that clear? Yeah, for the correct order of operations, we have 3 rules. Okay. I need to remember Simon's, Aiden. Let me mark you right now. Yeah, try not to be late. As you can see, it's very inconvenient to, change the attendance. I have to do the edit.
And Carly's here too now.
Who?
Carly.
Carly? Oh, Carly's here. So the
Yes,
first
I'm
time,
here.
okay, I'll mark you as present instead of late because the first time it might take you a while to figure it out.
Yes, I was having issues. I apologize, guys.
No problem. Yeah, Braxton? No? Okay. So Aiden is here. Lauren, Natalia, Aiden, Ashley, Lynn, Callie. Save it. Okay, so do you have the 3 rules in your notebook? You should take notes. Yeah, once you have the 3 rules ready, now let's use them. Let's use them for evaluations, all right? Yeah, we're going to do this first. Example 7. Example 7. The expression is 6 square minus 24 divided by 2 square times 3 plus 1, right? Okay. This expression has multiple operations. Do we have grouping symbols?
No.
No, but we have what? We have exponentiations, right? This one and this one, right? So we should take care of the exponentiations first. Yeah, PEMDAS exponentiation before multiply, divide, subtraction, addition. Yeah. So what is 6 square?
36.
What is 2 square?
4.
Yeah. And then I'm going to copy everything else. Yeah, there's no reason to change everything else. So I'm going to just bring everything else down. Minus 24, there's divided by times 3 plus 1. You're going to do the same thing, okay? Yeah, the only thing that has changed is we evaluated 6 square and 2 square. Everything else remains the same. We copy exactly what they are. Okay, so now let's look at this step. We don't have exponentiation anymore, but we have subtraction, division, multiplication, addition. Which one go first?
Multiplication.
Multiplication. Let's look at this part. Okay, yeah, that part I can actually take out right here. 24 divided by 4 times 3. That part only has multiplication division, right? What's the rule
Yeah.
number 3? What's the rule number 3?
If there's only multiplication and division in the expression, then you go left to right.
Yeah, go from left to the right. Exactly. We don't do the multiplication first because we see the division first, right? Yeah, from left to the right. Yeah. So we should, yeah, we should do the division first. So 24 divided by 4.
It's 6.
Yeah, and then multiply by 3.
It's 18.
Okay, so that is the yellow part. And then I'm gonna copy everything else. Yeah, the yellow part, we evaluated. Why do we do the yellow part first? Because the yellow part has multiplication and division. We should take care of them before addition and subtraction, right? Yeah, this is a
Right.
subtraction, this is division. Uh, this is subtraction, this is addition. We should do that later. That's why we do the yellow part first. And the yellow part turns out is 18. All right. So every step, yeah, the first step we took care of the exponentiation. Second step we took care of the yellow part, the multiplication and division part, right? Next step, 36 minus 18 plus 1. This expression only has addition and subtraction. Tell me please, what's rule number 2? What's rule number 2?
If there's addition, subtraction, and expression, we go from left to right.
Yeah, go from left to the right. So go from left to right, we should do the subtraction first. What is 36 minus 18?
18.
18. Yeah, bring down plus 1, and what's the answer?
19.
19, right? And that's the answer. That's the correct answer. If your answer is different from that, you probably mess up something in the order. Let's practice more. Yeah, any question about this example? We used all the 3 rules, and those 3 rules are all what we need to apply when it comes to the correct order of operations. Let's do this one. This one, okay. Simplifying or evaluating the same purpose. Yeah. Apply the correct order of operations to get the value of the expression. All right, do we have grouping symbols?
Yes.
We do see 3 parentheses, right? We see 3 parentheses, but actually only this one. Technically, only this one is a grouping symbol, right? The other 2 is just to frame the negative number. It's just to frame the negative number. Okay, so PEMDAS, we should take care of the content in the, what is it?
Empty.
In the grouping symbol. So we are going to evaluate the content in the grouping symbol. We copy everything else. If you have no reason to change them, you do not change them. You keep them. You just copy exactly what they are. And then minus this, and then, okay, let's see what is inside the parentheses, 10 minus 13.
-3.
93, and don't forget to keep this parentheses. And this time the parentheses not exactly grouping symbol anymore. It's just to frame the base 93. Yeah, and then times. Do we have a multiplication here? Even we don't see it. Do we have multiplication here?
Yes.
Yeah, okay. Yeah. So very good. So no, we have no grouping symbol now, right? Yeah, we still have 3 parentheses, but those 3 sets of parentheses are just to frame negative numbers. Negative numbers. Okay. PEMDAS, after grouping symbols, we should take care of what? Exponentiation, right? Okay. Yeah, we have this. This is power and this is power, right? I'm going to evaluate them separately. Yeah, on my scratch paper. Right, 2 scratch papers. Yeah. In this one, I do -8 to the power 2. In this one, I do -3 to the power 2. You can adopt the same strategy. It's pretty works pretty well. Yeah, like organized. Sometimes how do you write mathematics matters. You write a mathematics the expression in a formal way contribute to a correct answer. Otherwise, you confuse yourself or you go the wrong path. What is -8 to the power 2? What's the base? The base is -8, right? Anyone help me with this?
+64.
Positive 64. Awesome. Positive 64. Okay. And similarly, 93 to the power 2. You see how do I write them? Right? I write 93 times 93. I use 2 parentheses. What do we have?
9.
9.
Positive 9. Okay, let's replace the answers. Let's replace the yellow part with the answers. So the first yellow is 64. Copy this subtraction. Second yellow is 9. Copy everything else. Multiply by 92. The expression becomes simpler and simpler after every single step, right? After each step. Yeah. In this expression, we have subtraction, we have multiplication. What do we do first? Subtraction and multiplication. What do we do first?
The multiplication.
Yeah, we don't go from left to the right, okay? Yeah, there's a condition. If the expression only has addition and subtraction, go from left to the right. If it only has multiplication and division, go from left to the right. But here we have subtraction and multiplication. Multiplication is higher level, has a higher priority. So we should do the multiplication first, this yellow part first. So bring down 64 minus. What is 9 times 92? The yellow part. Yeah, you can do
Negative
another.
18.
Yeah, negative 19, exactly. 9 times 92 is negative 18. Yeah.
18.
So minus negative 18. Minus negative 18. This kind of problem might confuse you or challenge you when you took the algebra foundation class, right? How do we find 64 minus negative 18? How do we process minus negative numbers?
It's positive.
It turns to positive.
Exactly. Positive. Yeah. Or you know what? Remember earlier I said negative sign is like a opposite, right? Yeah, if we only look at this part, if we only look at this part is the opposite of negative 18. What's the opposite of negative 18? Positive 18, right?
Right.
Yeah, positive 18. And what is 64 plus 18?
82.
82. And that is the correct answer of this expression, the value of this expression. All right? Any questions? We have 10 more minutes. 10 more minutes, we are going to cover absolute value, okay? Yeah, we have another concept, absolute value. Absolute value of a real number is denoted as this. Yeah. Let's say A is any real number. And if we use two vertical short bar to frame A, and this notation represents the absolute value of number A. It is the distance between the number A and 0. Okay? Yeah, number A and 0. So firstly, take time to understand and memorize the definition of absolute value. Absolute value of a number. It doesn't have to be integer. In this exercise, all the numbers are integers, just to make it easier. The absolute value of number A, denoted by this, is the distance from 0 to A on the real number line. Because absolute value describes the distance, it is never negative. Could the distance be negative? You travel we wish, right? We wish to have another space to travel back, but no. Distance has to be non-negative. Means the distance has to be bigger than or equal to 0. Bigger than or equal to 0. Yeah. All right, let's apply the definition to evaluate the given absolute values, right? I start from this problem. Yeah. I'll start from absolute value of 5. I will draw the real number line. Real number line has two directions, right? This is a positive, this is negative. Let's say the orange is in the middle. Yeah. And this is 1, 2, 3, 4, 5, 6, and so on and so on. This is negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6, and so on. So this is a real number line. All the points on the real number line correspond to all the real numbers in the real number set. Yeah. We are looking for absolute value of 5. And by the definition, it is the distance between 5 and 0. This is 5. This is 5. This is 0. And what's the distance between 5 and 0?
5.
5, exactly. Awesome. So it's just a 5, right? Very good. And let's look at the part A. Part A, we are looking for the absolute value of -3. -3. Okay, so let me change the color of the pen. Yeah. Where is -3? -3 is right here, 3 units to the left of the origin. The origin is here. By the definition, absolute value of -3 is the distance between the number and the 0. What's the distance between -3 and 0?
3.
3. Positive, right? Is positive, yeah. So absolute value can never be negative. If we have a negative number, the absolute value of the negative number will still be positive because of distance, right? Okay.
Right.
Yeah, anyone can help me to complete part C? What's the absolute value of 0?
0.
Yeah, 0 exactly. Yeah. So because the distance between 0 and 0 is just 0. Yeah, they are the same point, right? Let's see. This question. Yeah. How do we differentiate between those two expressions, A and C? Yeah. Part B. Part B is easy. Yeah. Quickly tell me what is part B?
6.
Yeah, 6. Distance between 6 and 0 is 6. Yeah. And A and C looks very similar, right? Yeah. A is that. C is that. Right? The first one, the negative sign is in the absolute value, and the second expression, the negative sign is outside that. Yeah, let's figure out the values of the two expressions. Let's see what is A, part A. This is part C. What is the absolute value of -8?
8.
A positive?
Yes.
Yeah.
Exactly. Yeah, because that's the distance between -8 and 0, right? What about part C?
8.
Still
I don't
8?
know.
You said
Yeah,
it can't be negative.
remember structure, anatomy, right? Remember that? Let me see if I can get more colors. Change this to,
So does that mean that you would just like, if the negative outside of those, like, I guess, like lines, you would just remove the negative and it would still be 8,
yeah,
and then you add the negative back?
yeah,
Okay.
exactly, yeah. Or you can
Yeah.
understand that as the opposite, right?
Right.
Okay.
Yeah,
Okay.
opposite. Yeah, the opposite of the yellow. Yeah, the yellow is 8. The opposite of 8 is what?
Okay.
-8, right? Yeah, the yellow part, I only have one highlighter, one color. The yellow part is 8. And attach the negative sign in front of it. So the answer is -8. They're different, right?
Okay.
Yeah. Okay, let me challenging you just a little bit. Challenging you a little bit. If you have part D, and part D is this, can you help me to figure out the value? -8.
Hmm.
Yeah, those are good
Negative.
problems. Okay. Yeah, let me add one more. Part E. Yeah, those are good problems. You should have them on your notebook and look at them repeatedly. Part D. What is the value of part D?
Um,
Yeah, try the color, try the structure, you
So
know?
it would still be -8, right?
Exactly,
Okay.
awesome. Yeah, because the yellow part is 8, right?
Mm-hmm.
And keep the negative sign in front of it. My board, part of my board is damaged, so I cannot write that. Let me fix it. Yeah, it is a -8. Exactly, very good, very good. Yeah. What about part E? What about part E? If you use my strategy, like see the negative sign as opposite, you can get it done very fast. Yeah, how do we see part E? The opposite of the yellow, right?
Right. So it's
What is
positive 8. So it's positive 8. Then you gotta bring the. I mean, still put the negative in front of it.
And so it's still 8?
just 8? Positive 8. Opposite of negative 8, right? Yeah, opposite of yellow. Opposite of we are looking at part E. We are looking at part E. Opposite of negative 8 is a positive 8, right? Do you see that?
Okay.
Yeah. So please have those in your notes. These 4 expressions. This one, this one, this one, this one. They look similar, but they are different. Structures are different, right?
Yep.
Yeah. And about those exponentiations, when we talk about PEMDAS, I touched them a little bit. So today, we went over some of the questions on this worksheet. And this worksheet would be one of the 4 worksheets that you have to submit for your grade for the essential class. And so take your time. You don't have to submit it tomorrow. How about within a week?
Okay.
Is that reasonable? Yeah. So download it. Yeah, download it. If you have like a digital, like a board, like a mine, you can write it on and then save it and send it to email to me, right? But if you don't have that, you can download it, print it out, and solve them, and then scan them, or take a picture and then email it to me. All the submission
Okay.
will be through email.
Okay.
All right. Yeah. So we have one more thing here: comparison. Yeah, compare numbers. Just to try to use a real number line. I'll see how do you do on that. Yeah, that's for today. All right, guys. If you have any questions, feel free to email me. Yeah, I'll be here for you to answer questions. I'll see you tomorrow.
Yeah, see you tomorrow. Thank you so much.
Yes,
Tomorrow.
thank
No
you.
problem. Don't forget to watch the video, section 1.1, 1.2, and start your homework in MyLab Math. All right.
Okay.
And
Okay.
Lauren, I'll see you in Zoom. After I close this, I'll dial in to meet you in Zoom. All right.
Okay.
Okay, guys. I'll
Thank you
see
so
you
much.
tomorrow. Bye bye.
Bye-bye. Thank you.